What if a single vehicle could seamlessly transition from highway to railway, transforming how we think about transportation forever? Stay tuned. Today, we're joined by Kevin Damoa, founder and CEO of Glide Technologies, who's turning that bold vision into a reality. A combat veteran turned visionary engineer, Kevin has left his mark across some of the most cutting-edge companies in aerospace and mobility, from designing rocket logistics systems at SpaceX to managing the F-35 fighter jet program at Northrop Grumman. His latest venture, Glide Technologies, represents perhaps his most ambitious project yet, an autonomous road-to-rail vehicle that could revolutionize freight transportation while integrating clean energy and advanced automation. Kevin brings engineering excellence and entrepreneurial drive to tackling one of logistics' greatest challenges. So let's hear about it from Kevin himself. Welcome, Kevin.
Hey, Chris, thanks so much for having me.
This is like Transformers meets every kid's train fantasy, what you're building here. It's super cool. But
Thank you.
Before we get there, I mean, like you've got this wild background, and it's like spans so many industries, so many cool companies, so much like life experience stuff too. Could you just talk a little bit about like your background and like how that, like how you went from that to, founding Glide Technologies and coming up with this idea?
Yeah, absolutely. Thanks, Chris. So I've been in logistics for 23 years. It's my love note to all the logisticians out there. I joined the military at age of 17. Right after 9/11, I wanted to do my part, so I joined the U.S. Army. And U.S. Army took me a lot of places, and one of the places that it took me was to a rail line where I did railhead operations prior to and while deployed over in Iraq with 3rd ACR. And then got out of the Army. After my 6-year stint, went over to California to pursue the Hollywood dream. And during that path, I saw California was on fire. So I joined the California Air National Guard to support them in their mission to fight fires. So I did that from 2007 to 2018 is when I retired from the Air Force. And then, my first big boy job was with SpaceX. I'm the first person in the world to commercially ship, test, launch, recover, and they relaunch a rocket alongside those great folks at SpaceX. Shout out to all the SpaceXers out there. Before going off to Northrop Grumman, supporting with the F-35 program and supporting our war fighters in the air, throughout the world as we launched that beautiful platform out. To jumping right back in the startup world. Did some executive stints at Romeo Power as an early employee, at XOS Trucks as an early employee and executive, at Canoe as an early employee and executive, before going off and doing my own thing as a consultant, working at companies like Hydroplane and Zero Lab, and working with companies like InRide, for example, on some great programs and projects that really elevate the way that we move things, before helping Harley Davidson out with their first e-bike, Serial One, which brought me to the moment that we have today with Glide, as we look to, as you say, transform literally the way that we move things on road and rail.
The world operates on logistics. I mean, I don't think people appreciate how complex our logistics infrastructure is. I mean, we order something from Amazon and it shows up same day often. It's just this magic that happens, but we don't think about all the stuff behind it. I mean, could you talk a little bit about as somebody in logistics for a long time, what was it that excited you about it, and what were some of the real big challenges you saw there?
Yeah, of course. I mean, the thing that excites me is like special forces for regular people. I think logisticians are like superhumans, and the reason why I say that is because not one day is the same. Not one package is the same thing. And even if you have something that you package multiple times, the way that it comes in and out of your door changes hands, it changes people, it changes processes and speeds and costs and everything else. It's the most dynamic, thing you can experience. And within that, the inherent problems that comes along with that fluidity, that fluidness, of the process, where everything is dynamic. And, best laid plans need best laid plans and need contingency to those plans in order for things to be effective, is the challenges that comes, with logistics that keeps your head on a swivel, that makes, logisticians so dynamic. And like I say, it's a love story, where you have like pain on one end and then, pure joy on the other end when you deliver something on time at the cost it's supposed to be to a customer that is waiting to deploy great product on the other end. If you aren't that customer.
We always talk about the last mile problem in logistics, right? And like, it's easy to get it, to the ship, I guess, from the factory to
Yeah.
the ship, but then like,
Yeah.
from there, it's like, what now?
Yeah.
So, so how, like, talk about like, how you're bridging those gaps with all of this.
Yeah, absolutely. So the way that we look at things is via first principles, looking at global maxima. So, not just looking at the corridors and how we transport on either road or rail, but looking at all the material conveyance in between to get it from that place to that place, removing some of those critical touches that are in between, destination to destination, mode to mode, node to node, as well as all the back end processes. A lot of folks don't know, but logistics is still very, very caveman, antiquated process where you are exchanging paper, right? Hey, print out 3 copies of this bill of lading and give it one to the driver.
Yeah.
I keep one and I put one in the system, and that happens today all over the place. Where you have a clipboard with a person walking along things, but digitalizing that process as well, and then at the same time looking at it from a global perspective in regards to carbon reduction and throwing that into the equation. And then the last step, looking at the geopolitical aspects of it for the folks that live marginalized to these ports, railroads, or other industrial parks, and then baking that into a solution that covers all of them. And that's what Glide does. Glide, eliminates the different touches throughout the process. It streamlines the process to go from boat to road to rail and then to road again, and eliminates all of the paper documentation and all the brokerages that are there, and then it cuts out all of those emitting pieces of equipment along the way: forklifts, cranes, drayage trucks, trains, cargo ships, roll on roll off trucks, all baked into
Yeah.
one seamless vehicle, that is reduction in itself. So it's as easy as
Well, yeah.
gliding, right?
Yeah, as easy as gliding. And I mean,
Yes.
and when you look at how it operates, it really does look that way. So,
Yeah.
one of the things you said there that I think is really interesting is sort of like bringing, like logistics to more, like maybe either more marginalized areas or like more remote areas or, countries that have, like incomplete infrastructure or,
Absolutely.
like where it's just simply difficult to install infrastructure, too, So
Yeah.
can you talk about like how you solve for some of those problems?
Yeah, absolutely. So when I think about gliders, gliders are like this off-road beast of a truck train, where we can operate and
Truck train, I like
develop
that.
it. Yes, it goes shroom, right? It's choo choo and zoom at the same time.
And it transforms
But
too.
and it transforms exactly. But I mean, it's for developing and austere locations, right? In the developed nations, you have infrastructure that is underutilized or utilized too much in the comparison between road being congested and then rail being underutilized here in the United States. And then you have your developing where you don't have the infrastructure in place. You may just have a rail track, like in the case of like Africa, but you have all this like rough terrain that you have to figure out. And then you have your austere, your war-torn locations, where you have this rail infrastructure put together, but war has taken a toll on the rest of the infrastructure, or roads are too unsafe to operate on in the contested environment, where glides foots the bill. Given that we are an off-road vehicle, we do utilize geospatial mapping to go around bad obstacles. We can attenuate loads on the vehicle itself so that the goods on top of us stays safe while it transits. And then it does provide opportunities for developing countries to say, do I really need to install a road in these locations? Can I just do like a gravel pit, or do a dirt road, and then stand up rail infrastructure? Is going to be expensive in the long run but cheaper over the course of things, and I can share this from state to state, country to country, and we have a corridor that can do that quite easily, at the same time leveraging the low cost per ton mile that rail is associated with. Um, and the ability to transport a lot of goods all at one time, while offsetting that gross vehicle weight that we see in some countries. So that's how we envision glide across those three paradigms.
Take me from the factory to
Yeah.
like the end point, and just talk about like where you guys fit in, and like how you maintain all of that.
So a customer, say we're Amazon. We haven't signed up with Amazon yet, but hey, come on, Amazon, we're ready for you. So
Yeah.
we Amazon had, they deal with 20-foot equivalent trailers all the time in small parcels in that LTL, FTL shipment, but they don't leverage rail as
and
much
and
as
when
they
like
should.
explain that acronym for people who aren't familiar with it. LTL.
Absolutely, absolutely. Yes, LTL is less than truckload, so a half of a 50-foot truck or a 53-foot truck or a 20-foot container or a 40-foot container. 20-foot is called a TEU, 20-foot equivalent unit, and so forth. So Amazon loads up packages into these containers, and then they put them on the back of a semi truck, and the semi truck goes and delivers it to its destination, whether it's a consolidated center or your final mile, whatever it may be. But they don't use rail. So in our aspect, the glider would pull up at Amazon door, be loaded up, and either we will bring a container to load up, or they can put a container on top of it. We would drive over to the local rail spur, and a lot of the times these Amazon facilities are within feet of a rail spur itself. We'll drive over to the rail spur, get on it, drive down it, bypassing all traffic along the way. So the road guys are not like, man, that train is actually going and it has the Amazon logo on it. And then when we get to the other side, say it's a distribution center, we'll jump off, drive over to the distribution center, let the folks unload, and we can do that round robin all day, every day. In between the step, you didn't hear about me saying, hey, a forklift had to come in to the right size this, or
Yeah.
we didn't have to like transload this from like road to rail, which is the biggest barrier of entry. It was all done on one vehicle on both sides of the fence, and very, very cheaply.
The challenge there too is that it's bidirectional in terms of like you have to move these vehicles. Like you get them there, and now you got to get them back to pick up more loads.
Absolutely.
So like
Yes,
how
yes,
do
yes.
and I know there's a lot of infrastructure and complex negotiation between taking a load, then picking up another load nearby and bringing it back to where you want it to be, and keeping everything, because the more you keep everything busy, the better it is, right? So
Yes,
how do you
utilization is the name of the game.
yeah, yeah. So talk about the utilization piece of it.
In a beautiful market, you want to do a bread run, round robin, where you're dropping off at one distribution point and delivering at another distribution point. But the great thing about our technology is we'll parse it out within the region. Say we picked up for Amazon, and Amazon doesn't have an order for us to return to, but we have, say, a trash company that needs to be picked up, or an aggregate company needs to be picked up and brought back within the proximity of our next Amazon or whatever Walmart load. Then we'll service all those customers at the same exact time, on that same rail line, because the rail line is our primary customer. So we'll be agnostic to every commodity. So our claim to fame is any road-based trailer, any rail-based cart, any commodity, we will allow access to the rail, because it doesn't have to be packaged in a form that is required for the rail anymore. You
Right.
have a container that you can just load anything else on, whether it's an open top gondola, or for lumber or aggregate or sand or agriculture, or small parcel or large packaging palletization, that can fit inside a container. Anything that fits within that special box, we can put on our glider and go.
And I don't think people really realize, and I could do a whole show on this too, because I think it's absolutely fascinating. But the shipping container itself, and the revolution that a shipping container was, like standardizing how things get shipped, completely transformed everything.
Yeah, I mean, there's a book called The Box that I recommend to every
Yes.
reader, if they want to learn about containerization. But I mean, now they're homes. Now a container can ship anything and everything, and then you could put a swimming pool, make it a swimming pool. You could make it a home. I mean, it's a Swiss Army knife.
Yeah, well, and I know, like, it's interesting too, because when goods ship from, say, China,
Yeah.
they purchase a new shipping container, put it on a ship, bring it here, it gets off at a port, and then they just sell that container. after
Absolutely.
they unload it, right? And then
Absolutely.
so there's like tons of extra
Hmm.
containers available, and it can be intermodal shipping, or it can be a house, your new house, right? Right.
Absolutely. Absolutely.
You take a container full of Amazon small packages to a destination, and then you pick up aggregate. Like how do those are very different loads.
Absolutely.
Like, how do you manage things being so vastly different in terms of their weight and the weight distribution and the way they move and all that?
Yeah, I think the thing that we get away with is within the United States, we have, the gross vehicle weight requirement, right? So anything that's, 40 to 80,000 pounds for a 20-foot container, you have like a 40 to 60,000 pound limit with with the 40-foot container, you can get up to 80,000 pounds to include your vehicle. So you're kind of limited to that 60,000 pound as well, because most vehicles weigh about 20,000 pounds. But anything that fits within that number, you can ship, right? If it's toilet paper and you fill up the whole thing, it's like, hey, sorry, dude, you didn't get the weight, but you got the mass equation. But like aggregate or small parcel or anything else, like or regular fluids in oil and gas or water, it all has to drive underneath that same weight. So
Yeah.
that's where the variability is. So the problem that we have on our side that we have to solve is, how do you attenuate those loads? How do you make
Yeah.
sure
Yeah.
that those loads can actually be balanced on your vehicle? With the solids are no problem, right? The aggregate, the lumber, the small parcel, those things. But when you get into the liquid form, how do you attenuate those moving loads the way they do? And that's the problem that
Yeah.
we have solved, on it as well. So we have a way to attenuate the loads as we go down as well.
So talk about that technology, because that sounds really interesting. I mean,
Yeah,
let's talk about all the technology that goes into this, because
yeah,
there's a lot here, right?
absolutely,
So
absolutely. So
yeah.
typically, sorry about that. So typically, it's done via pneumatics. On most trucks, air rides are how you handle it. We electronically actuate or attenuate those loads instead of utilizing pneumatics, so that we don't have two disparate systems on board. We do load checking. So you put the load on, and then when the load is on, our truck will or our gliders will drive a little bit and see how the load shifts. And then as the load shifts, we can actually, rebalance out the load, via actuators or suspension based on the load characteristics. And we do it for everything that goes on top of our gliders. We had all that data digitalized, because I don't know if when you drive down the road, you see these loading scales. You have to report
Yes.
everything that's on the road. So we actually put all that data, we grab all that data digitally on the vehicle, and then we store that data so we can send it off to the DOT as well as a part of the process. So, it's another step function that's built into how we do our technology intentionally.
You talk about a lower carbon footprint, right? I mean, I assume there's besides the fact that rail is significantly more efficient than other modes of transport, and you're taking all these other things out. Is there electrification in this? Like what are some of the other like sustainability technologies that you have built in here?
Absolutely. So every glider is battery powered, but it's a hybrid. So on one end, we have a range extender that is agnostic, so we can do JP8, LPG, biodiesel, regular
Okay,
gas,
you're gonna have to
or
explain
hydrogen.
those acronyms too.
So sorry. So sorry. So JP8 is the military's fuel, right? It's like kerosene. Biodiesel is diesel, but it's made clean. It's typically from vegetable oil, animal oil, whatever it may be. Maybe not
Right.
animal oil, but vegetable oil, corn oil. It smells like French fries. Regular diesel, and then gas, and then hydrogen. Hydrogen is another range extender that we're looking at as well
So,
for folks that are
it
port
can,
adjacent.
are these like multi-fuel kind of vehicles, or do you have to have like choose each vehicle for the path that it's going to take?
Yeah, we'll have to choose the vehicle for the path it's going to take. The great thing about us is we have a lot of real estate. Each glider is about 8 foot by 22
Yeah.
feet. So the battery's 300 kilowatt hours only takes up so much. So you have all this real estate to have a conventional engine up front, or have a conventional fuel cell system up front as well, to serve that purpose. And then with that being a hybrid, we don't have to put in costly charging infrastructure in place, or if you have charging infrastructure, you can charge your battery. But
Yeah.
we always give folks, we love variability, especially in, again, austere locations, developing locations, or even developed locations where charging infrastructure is hard. It's harder. No, it's hard everywhere. So we want to be that one-stop shop that solves it for everybody.
Well, and I don't think most people really understand how trains work either. Trains are actually
Yeah,
electric,
they're actually
even though
electric.
they're diesel train, but they're electric
Yeah,
because
yeah, they're electric.
that's just a generator to charge the system, right? Can you
Absolutely.
tap into that power as well?
Yeah, so we haven't looked at that, but I mean the same as same as a train. I think that anything that has any combustion to it, they had it is an energy source that propels everything else, with the exception
Yeah.
of of course your drivetrain that in the regular ICE vehicle that drives a crank and everything else. But we won't get too far into that. But yeah, I mean it's the exact same methodology.
Since these are, like they're designed to be interchanged and move and resorted and different things added on. I mean, they're probably not prohibitive ultimately to like be able to swap out those powertrains or like because it's just a generator. You just have to kind of
Solid
drop a
generator.
generator
That's
on a
all.
platform, right?
Absolutely, that's all it is—a generator and a tank, right? And then you have your battery plate. Your battery plant stays on board. That's a constant. But other folks is like, hey, do we have the packaging space for two small tanks or one small tank, and then the actual powertrain itself? Yes, we do. So that's all it is.
Additionally, you guys are adding in autonomous functionality to these
Yes.
vehicles as well, right?
Yes.
Could you talk about how that works? I mean, there's a lot of things
Absolutely.
going on here.
So we leverage sensor fusion, so a combination of lidar, radar, sensors, as well as cameras for visual inspection, and we utilize that because like we are borrowing from an industry that exists. So it's the high rail trucks that are currently utilized to inspect track. We borrow from that industry. That industry that process is very manual, where you have a driver that gets out of the truck, pulls pins to actuate the front rail wheels and then the rear rail wheels. And then they get in the truck and they put a piece of Velcro over the top of the steering wheel so they don't accidentally move it. It's a very dangerous and antiquated process. So what we
Yeah.
do is we actually drive onto the track. We utilize sensor fusion to do geospatial mapping so we can access where the track is. Once we get up to the track, we realize positive acquisition of the datums on the track so that then we automatically put down our rail wheels. When we start moving along, one thing that we can do as a part of that, since we're driving over the track, is do visual inspection as we go down the track, and that helps us out to navigate it as well as prevent derailments as well. And for the rail operator, we can actually give them that information that helps them out with lowering their insurance costs, supporting with preventative maintenance on their track, and as well as sending a signal for derailment mitigation as well. And that's how our technology works on that side. And that's on both of our platforms, not only Raiden, the fully unmanned one, but on Glider M as well. That is our manned vehicle too.
When you get on the rail line, attaching it to a locomotive is probably more efficient to run it.
Absolutely.
But you could run it, I would imagine. Can you run it independent of an engine too, just if you have access to the rails?
Yeah, absolutely. So we don't link up with locomotives at all.
Oh, you don't?
So
Not at all.
no, yeah, not at all. Not yet. Not yet. That
Okay,
that isn't
okay.
what we've proposed yet. So our value prop is to like offset the dwell time that a locomotive typically sees. So a lot of folks don't know, but a locomotives when they're at the ports or any destination, they have to be long enough to meet their units of economics to actually pay for that locomotive itself, and that's
Okay.
typically about a 2 mile train. In some instances, it takes about 2 to 6 weeks in order to load up a locomotive.
Oh,
So what
wow.
Glide does, we actually jump in front of that train, do a bunch of deliveries, and then that train departs. And say that train is coming head to head to us, we can take a roadside and then drive alongside that train as it passes by. Then we can jump back on the rail. But we see our units of economics as better than a train from the standpoint of just pure speed. Not
Yeah.
not the efficiency associated with pulling a whole bunch, but the efficiency to ship a whole bunch in a short amount of time during their dwell time is the asset that we utilize for Glide.
And time is money too, so that's got to make it more cost
Absolutely.
effective as well, right?
In doing that, in that same breath, is we're increasing the capacity of that rail line. So as
Right.
that train sits there and dwell, you have a bunch of open capacity that you're not utilized. So we're leveraging that capacity that is there readily available. So the rail makes a lot of more money.
Well, and I know one of the problems with U.S. rail is that like different people own different parts of the railway, right? And so
Yes.
like who they
Yes.
license it to depends on who gets to use it at any given time. And like you just mentioned, if the train starts to come through, you just get off and get on the road, and then get back on the rail when you're out of the way. So like those like long train delays that we see in our system don't impact you, right?
Absolutely. You have the ability to leverage it. And the other great thing about the rail system is all on a schedule. I mean, you're not going to see an ad hoc train that's going down the line. I mean,
Yeah.
everybody has that schedule on when we have capacity and when we don't. So our system interacts directly with the rail system so that we know when we have to come off or get off of, come on or get off of it as well.
That dwell time or like sitting around waiting is really inefficient use of our infrastructure. I mean, like the rail
Absolutely.
itself, which you mentioned is kind of an expensive upfront cost to lay the rail, but like the more
Hmm.
utilization you get out of it, I would imagine that just drastically changes those economics.
And then, now that you can like leverage rail a lot more, now you have less road construction. Now you're not sharing the road as much with big semi trucks because now rail is more accessible. So you now have freed up congestion on the road.
Right.
So it's like it goes hand in hand. And we do a thing that I like to call corridor balancing with that. Freight moves on freight, passengers move on passenger transit.
Yeah, well, I love the fact that you can get out of the way so that, like, if I ever take a train anywhere,
Yeah,
I don't have to wait for the big long freight train to go by. And that's another thing too. I mean, like those
absolutely.
giant. You mentioned that they have to get, like, take 6 to 8 weeks to get these trains, filled. And then, like, I'm sitting there, like, I got to be at a meeting in 10 minutes, and I got
Yeah.
30 minutes of trains still coming by.
Absolutely. Cancel that meeting.
Yeah, yeah, forget about that. Yeah, and there's no hope. You can't turn around and go somewhere else because it's
No,
miles of
not at
train.
all.
I mean, obviously there's military applications. You talk about like sort of Africa, like as a destination, and like Africa's really interesting because I think it's one of the most compelling growing markets right now in terms of
Absolutely.
like and the thing that's interesting about what's going on in Africa is like they're like kind of leapfrogging technologies. They have the benefit of
Hmm.
not having a lot of the infrastructure in place, that legacy infrastructure. They're not laying down, copper wires everywhere and things like that. So like it
Yeah.
kind of have the opportunity to build modern. And like I think, the logistics though still comes a problem because like the United States, like North America, it's a very, very big place, right? And it's
Absolutely.
and it's
Absolutely.
so many different nations. And I gotta
Hmm.
imagine like even there with like the railway, they may not even be, from country to country compatible rail systems, right? So you could probably get
Yeah,
off
absolutely.
one and, like drive over and get back on a different rail, that's operating differently. So talk about like how that impacts, things in sort of like growing economies like that.
Exactly that. Exactly how you described it. Say you have disparate rail infrastructure or corridor infrastructure, but there's one thing that stays the same: the ground doesn't change, right? The
Right.
ground you don't have different ground as you cross borders. So we can utilize what is there in order to access what is new, or just by multiple states, countries having the same glide technology in it would be inspiration enough for these folks to develop an intercontinental transit system that goes between each one of these states to bolster their economies. I think within the United States is great because it is the United States. Europe does the same thing. It is a EU as a united country. Africa hasn't yet done that yet, but if they do, and they do have a shared ecosystem, then the amount of potential in that country or that continent is exponential. So we're hoping that we can be a catalyst for that. Making transportation easier to access, making commodities easier to flow between nations. Through a glide brand is the dream.
I think that as they develop, they're going to need a lot of materials that you can
Absolutely,
help deliver. It's
absolutely,
it's kind of a chicken
absolutely.
and egg situation, and you can help kind
Yeah.
of alleviate some of that chicken and egg problem, right?
For every single commodity. It's like, hey, you built widgets in one place, and I built the byproduct in another place, and then we ship it to these other place, and now you've created this circular economy for your continent because you have a shared ecosystem. You have an intercontinental, system of transit for all these goods and whatever state they're in.
Coming from a military background, you think in terms of like, like we talk about the internet as being able to survive anything,
Yeah,
and
yeah,
you're kind of creating a shipping and logistics system that can kind of survive anything, right? Because it's not
absolutely.
just, like there's natural disasters. I mean, if you're going to like tackle, a huge continent that has all kinds of different ecosystems and,
Hmm.
earthquakes and flooding and, that all that sort of thing, the ability to route around that's got to be really valuable. But like from a
Yeah,
military perspective, I mean, if you look at some of the conflicts recently, the rail lines have been the central discussion point
yeah.
around a lot of that, and the ability to kind of route around trouble has to bring an enormous amount of benefit there.
When you go to war, the last thing that is tore up is the rail. The rails are a lot of times bulletproof. I
Yeah.
mean, you have to have a really really smart bomb to take out a rail line because it's a long rail line, and with our technology, you can skip over a broken rail.
Yeah.
Yeah, I think it is the strongest corridor that we have outside of ocean. Nothing can change the ocean though.
Well, I mean, there's bad weather, but other than that, yeah.
There's bad weather. Absolutely, absolutely. Fair point.
So okay, so talk about the autonomy that you've got built in there into this. I mean, you mentioned that you have two versions of this. One that's driver that has a driver, one that's
Hmm.
autonomous. Like, how much
Yeah.
autonomy is there? Like, can this just like does this identify a problem in the rail and then just figures out how to get around it, or do you have to? Is that when somebody jumps in it and then like helps it figure out?
For our rating, we're actually building in scenarios on rail conditions. So we know for a fact, it's industry knowledge on what rail conditions a train can navigate if it's a poor condition, and we know what conditions where you have to get off the track or you're going to derail, no matter what you got going
Yeah.
on. So that's programming in the glider, and then there's scenarios that you don't know, and within those scenarios, our go-to is to get off.
Right.
And then there's a scenario where it's like, if you get off, you're actually going to be in peril because there's a huge drop, down a ravine.
Right. Right.
So, what do you do? Do you go backwards? So the glider has the ability to back off the track as well. And in that instance, we do have a human in the loop intervention that is say, okay, it's better to either wait in place for help or back off the track to get back on an adjacent road to go around that bit of debris or that bit of bad track that's there. So there's optionality with human intervention.
About that sort of getting off the track and getting onto the roadway situation too. I mean, do you, it's probably early stage to say it's going to be autonomous on the open roads at this point, but
Yeah, absolutely.
yeah. So I mean, I assume that's where a driver intervenes, but eventually, I would imagine that's going to be autonomous as well.
Yeah, and that's the dream for glider M. It's always going to be, well, I wouldn't say always, but for the most part, there will be a person in the vehicle with our abilities to pull a person out, and they do remote operations. For Raiden, that will be an unmanned operation. The great thing about rail, though, a lot of rail lines have service roads that are parallel to the actual rail itself.
Yeah.
So that all that line is all private. So our partnership with the rail line, extends out to that private road as well. So we'll be able to, run on that autonomously as well. On public highways, of course, we won't be able to do that without any kind of permits. But eventually we'll get there. Autonomy on the road is much quicker to coming into adoption with Waymo and with
Yeah.
the robotaxi and everything else than rail right now. Because within the rail line, there's only a couple folks working in autonomy, and we still have a bit of a hurdle to go.
It seems like that'd be the first place to do autonomy because it's
Yeah,
like you don't have to worry about where the rails are going. I mean, just you have to worry that they're
absolutely.
there, I guess.
Yeah,
But yeah, I
exactly.
mean, that seems like a really obvious spot for autonomy.
Rail is older than it's the oldest form of transportation. Big commercial transportation within the world, and it's the slowest to evolve. It's the most. It's really private, right? I will say that. Like you talked about earlier, there's 600 plus rail operators within the United States alone. Rail is still very, very private. There's seven. Well, that number's reducing with everybody merging. There were seven class ones, and then there's hundreds, 600 plus class two and threes. So you're dealing with an individual at each one of these things, and a lot of folks are like, I mean, I don't even know where to begin.
Yeah.
right? So it hasn't evolved in a while, and these folks are like, if it's not broke, I'm not going to fix it. But if your capacity is off, then that's a little broken, is what we say.
I mean, you mentioned these frontage roads, like along the paths of the train tracks. I could imagine, like, we start shifting the way our infrastructure works, because I know that the rail lines do own a lot of property on either side of
Absolutely.
their
Yeah.
railways, and like everybody's always like, because I've got a restaurant, I've got a train line just right down here, and I've got a restaurant that wants to use that space for parking, and you go in there for a second, you're going to get towed. Even though there's nothing
Absolutely.
there,
Absolutely.
it's like it's totally underutilized. I'm like, what's the deal here, man?
Absolutely. Absolutely. Eminent domain. That's the rail guys. They
Yeah,
even have their own police.
they used to have a pretty scary version of police back in the day, right? But
Yeah, absolutely. Absolutely. Absolutely.
yeah, those robber barons, of the old days.
Yeah.
Yeah.
Yep.
Uh,
Yep.
so like, tell me about like I'm sure you must have had like some like cool use cases where like like there's no way to like you can't get there from here, but like you've got the trick to do that. I mean, is there any like interesting like places where you've been able to apply your technology in a really unique way?
So we're looking at, working out in Kansas Proving Grounds in Great Plains. It's in Parsons, Kansas. It's an old military base, and they have some rail that is in kind of weird conditions. I'll use the word
Perfect for
weird.
you.
Yeah, absolutely. And then they have some road, but the road is in weird condition. Then they have a lot of off road that leads into to rail, where they have like munitions depots, whatever it may be. So that's the most, I want to say, fun location for us to operate in. It's like industrial park. You have all these different environments. Some are optimal, some aren't. But one vehicle can do it all for all types of commodities. Like they have munitions on board, they have containerization, they have aggregate, they have lumber, they have a commercial and residential site in construction that's going to be stood up, and that's exciting for us because we're like we can service all these folks, and create corridors for you no matter what you have in place right now. It's the exciting thing about that site.
It's like a ultimate playground for your transformer, right?
Yeah, absolutely, absolutely. We call it the Baja Bogey.
The Baja Buggy, I love it. I love it. Yeah, yeah. It's like, just go off roading. I mean, do you have like some versions with like really big knobby tires and everything?
They all have like big knobby tires on them and like active suspension on it as well. It's pretty cool.
Where are you in your journey? Right. I mean, like obviously you're building this, you're prototyping things, you're testing. I got to imagine there's a lot of regulatory and compliance and yada 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 things to get through.
Absolutely.
Like, so where are you on this?
We just raised an oversubscribed pre-seed round, which was phenomenal. It was led by Outlander VC, and we had Draper U, the Veterans Fund, Antler, and Capital Factory, amongst others, coming to our round. So that was great. But at the top of the year, we actually kicked off production on our Glide RMs. That's our manned version of the vehicles, with custom truck one source in conjunction with PACCAR. So we have those two vehicles coming off the line mid-October with both FRA and DOT certifications ready to go out of the box. And then we built Raiden, the prototype, and showed it at New Mobility Futures and right after reindustrializing Detroit back in July. So we're in process of going through the productionization of that and doing test trials and that to improve the scalability and the operability of that platform. And then we have Ezra 1.6, our proprietary software that isn't an AI wrapper, that isn't built in with a bunch of APIs, that it was coded at home. So we have 3 products in 1 year to launch out, with 2 of them being piloted this year, with 2 great customers.
I got to imagine your market for this could be enormous. I mean, like when we talk about like
Yes.
in the TAM that you're investing in, I mean, that's got to look great, right?
Globally, it's a $20 trillion TAM within the United States, just being conservative. It's about $100 billion, and that's just looking at road cargo. That's not even looking at the defense side, the contested side. And then right now, dual use is a big thing, and naturally so, given what's going on in the world. And then our local SOM, just our pilots that we have in the book and our book of business, is about $3 to $5 billion. So it is a very, very healthy market, logistists.
I can
So,
imagine it's probably not hard to get investors for that, right?
No, not at all. For a while it was.
Yeah, well, that's always hard, right? You got to dream. Who's this guy?
You got to dream. You got to dream. You're like, who's this guy? What has he done?
how's he transforming the
What has he
world?
built?
It sounds like a great group of investors for you. And so then
Yeah.
where does this go from here? I mean, like I could envision so many different evolutions for this. I mean, you're like disrupting, what you say is a 150-year-old industry. There's
Yeah, yeah,
that
yeah.
hasn't changed literally in 150
Yes.
years.
Not
I
at
mean,
all.
so
Not at
like,
all.
so I mean, like that, like when you talk about industries ripe for disruption, I would imagine this is probably one of those.
Absolutely, because I mean, incrementally, we're trying to like move the needle, but it hasn't been completely disrupted. And what we're trying to push forward is what we call logistics 4.0.
Yeah.
Making logistics as easy as gliding is our thesis and our mission. And that's how we pay rent. I talk a lot about paying rent. We're all here temporarily. Everything on this earth is all temporary, including the earth itself.
Yeah.
How are we all paying rent for that? And this is how Glide is paying rent. This is how Kevin Damoa is paying rent. And how is it going to be used? I mean, hopefully we will be the next form of transportation for everybody while leveraging existing infrastructure, while leveraging existing thought processes on how you move goods, but in a more effective, efficient way.
I could see, like your autonomous bed comes, picks up my, little, cabin, it's attached to my house, takes me out and puts me on a rail, ships me out to California and drops me off and takes
Yeah.
me to the hotel.
That's a dream. That is the absolute dream. I always say to folks, don't ship it, glide it.
Glide it.
Right? So it's one day you will be able to say, hey man, I'm not going to ship it via UPS. I'm just going to glide it. And I know it's going to get there.
I love infrastructure stuff. I love the things that change the world in dramatic ways. Like you mentioned the box. I
Yeah.
mean, like the container, like everybody's like, who cares? Like we're throwing those away, that's just for shipping. But it's like it's so transformative to the world, and
Absolutely.
like these kinds of innovations are super transformative, and I love to see this kind of stuff happening.
Thank you.
So congratulations on a very cool idea. Congratulations on your raise, and
Thank you.
I hope you have tremendous success with this. And I just want to say thanks so much for being on and sharing the story of your company and your incredible background too.
Awesome. Thanks so much, Chris. I really appreciate them. And it's been a real blessing, to be on the show and to talk with you about our experience and what we will do. And I believe we certainly will. I won't stop until we do. And I got a lot of push
Yeah.
in me.
Yeah, keep going.
Yes,
Obviously, you have
sir.
a lot of push in you. So yeah,
Absolutely. Absolutely.
awesome.